explain where this hollow earth theory comes from. And it's pretty simple. People got to think so far left or so far right that they can't understand anything. And I'm not saying they don't have the potential to understand. I'm saying most people really just don't want to know. They would rather have drama and fight and argue so they feel like they have some kind of purpose, when that basically just defeats the whole fucking purpose of being a human. Okay? So, let's go at this from a logical standpoint. Alright, we know that the earth can't necessarily be hollow because, well, it's sustaining itself. If it wasn't, it would be crushed due to gravitational forces. Alright, we also know that we have to have a magma core. We also have to have, well, we got a magnetic field, okay? So, you know, obviously we know we got a big giant dynamo beneath us. Alright, now, this does not, it's not a sphere. It's not a perfect sphere. Alright, it's not a perfect circle. And not the band, obviously. But it's not a perfect circle. And it's because we have magma and mantle, and our surface is basically the electron shell, the crust, the egg shell. Alright? Now, when this is spinning very fast, basically 1,000 miles per hour, now, obviously this is kind of slow when it comes to astronomical measurements, but to us, this is actually very, very fast. And when you have a rock-like planet, but it's malleable, when it's spinning like this, at the center, it's going to divot inward, basically because all of the centrifugal force is moving outward. So whenever, say you have a ball, a hollow ball, and you put water in it, you spin it real fast, all right? Whenever you do this, it's going to create like a cyclone up through the middle, all right? It's going to clear out the area for the middle, and you're literally going to have something like this, okay? You're literally going to have a hole that burrows in. It's not like it's burrowing necessarily like a mole would do, but it's an indention that is created because of this centrifugal force, all right? So whenever this story came along, where this guy was flying over the South Pole, and he said, "Oh, there's a big old hole there. Oh, it's hollow. The Earth is hollow." Okay, for one, we know it can't be hollow, but this is possible because the way our planet is designed. Okay, the way it is made. Now, this hole, I mean, I'm saying, I'd guess it'd probably be several miles deep, maybe a mile or two deep to several miles deep. All right. But nonetheless, the Earth isn't hollow, but the idea came from somewhere. And it came from this idea here, from this hole that was so-called, you know, and probably a couple other little ideas. But nonetheless, explaining it logically, this is the reason why. You would have a hole at the bottom and a hole at the top. You'd have an indention, a divot, because of the centrifugal force. Now, like I explained about Saturn, I don't know if I have a video about Saturn on this channel yet or not, but nonetheless, okay, Saturn spins really fast, 11 hours, you know, and that's the whole day, all right? So when you have something spinning this fast in gases, all right, these gases are going to cool as they move over the planet, all right? Once they've cooled, they're going to condense, and you're going to get a small storm, which this storm is literally the size of the United States, all right? But compared to the one at the top, it's very small. All right. So once all of this is pulled in and cooled and condenses, it's going to end up going toward the core, all right, of the planet. Now, I call it cold volcanism. There's cold volcanism going on here. This core is probably 7 or 8 times larger than Earth. But since you have the rings, actually this is a black hole, but similar to Saturn, I'm explaining. They have a lot of things that coincide with one another, even though the physics are a lot different. Now here, once it condenses and goes in, you have cold volcanism going on. Okay, so there is literally, the core is actually erupting magma and heat. Now, in the middle here, you have a subcore. Okay, so the subcore is literally being tugged on by these rings and the moons here. Okay, and from the tidal friction and forces that you got going down. So literally, this would be molting, and there would be cold volcanism. So there's inner heating inside Saturn. As this condenses and cools and moves up through here, it expands once it starts to get warm, okay? And then it comes out the top, which is the size of 3 Earths. That's why this storm is so huge, because all of the gases that were condensed are now expanded. And now they're going to start moving over the planet again and cooling once again. Okay? Now the reason this is hexagonal is because there is a wobble or a tilt inside here. So whenever it reaches its apex and starts to do its wobbling and rotating, every time it reaches an apex, that apex point is where it creates a corner of this hexagon. That's its apex point. And plus you have the rings that are helping it. Okay? So these rings, along with its wobble, are actually creating this giant hexagon at the top. So Saturn really isn't that hard. I don't know why physicists haven't figured this stuff out. I guess they're just waiting, like I said on that last video, waiting for evidence, or waiting for something to pop up, or waiting for somebody to say something. Look, waiting is not going to figure out shit. Start using your damn brain. Plus, when it comes to astrophysics, you can't apply numbers to everything. Numbers go on forever. Space is infinite. It goes on forever. Using numbers is almost ridiculous. Okay? If that is our source of understanding, it's ridiculous. Okay? Numbers can corroborate and verify, but you have to understand how the engine works, or you're not going to understand the numbers. The reason they can't figure out some of the numbers is because they don't understand how the engine operates. But once they understand how the engine operates, they can apply the numbers and then corroborate it. See, that's all the numbers do is verify, but you got to know what it's verifying. All we're doing is getting all the answers Jeopardy style, but we don't know the right questions. And that's what I'm working on. That's what a lot of people are working on technically that are crazy. But only the crazy people sit around and let themselves be brainwashed. So like I said, so it's a new term, cold volcanism. I don't know if it's ever been used. I don't know if it's actually a term, but I'm going to use it. And you can laugh all you want, because people would laugh. If I ever explained this to somebody and they wanted to fight and argue and they didn't want to believe it, they would sit there, oh, it's cold volcanism, it's retarded. How do you get volcanism that's cold? I mean, people say some of the dumbest shit when they could obviously know exactly what it means. If you're inside the planet and it's cold and it's still erupting here, then you have some cold volcanism going down. Alright? Just saying. People find the littlest thing and blow it out of proportion to try to make you sound crazy or stupid, when in reality what they're doing is making themselves look less intelligent, like they need an explanation, when you already gave them one, but they can't seem to wrap their minds around it. See what I'm saying? Just throwing that out there. I'm a little aggravated right now, so, and I might just stay that way, because really, I mean, it's like when you try to be nice and peaceful and all that, what's so interesting about nice and peaceful? You gotta be a dick. And here's Mercury, alright? I think this might be a theory, but this has always been my theory. Why is Mercury just a big ball of iron? Now, physicists, like they say, this is their favorite explanation. Oh, something hit it, knocked the crust off. Okay? There was a collision. Look, that excuse has been... Look, I understand things hit other things in space, but not too often because of the vast space that you have in between them. So, using that as an explanation all the time just is kind of getting old. How about we use common sense here? Well, let's see. In an accretion disk, if you're going to be close to the sun, you got to be pretty heavy. Well, I'd say only the iron would be able to survive this close when it's accreting, and all of the solar winds are literally going to carry all the silicates and any lighter material out into the solar system, and only the iron's going to remain. So, literally, the reason why Mercury is a ball of iron is because that's all that could survive when it was that close to the sun. And I believe, literally, when it comes to the solar winds sweeping the lighter materials out, I say this has something to do with our moon too. Okay? Now, I'm not going to say that the collision of Theia and Earth isn't what happened. I'm not going to say that. There's some evidence that corroborates it, but I think there's a little bit more to it. Okay? Some of that was actually accreted in this disk, and some of the moon actually is, I would say, a lot of the material that would have been in Mercury. Okay? And that the Earth captured the moon, or they formed in the same accretion disk and were moving at roughly the same speed around the sun until they ended up getting close and kind of hitting each other, and then the Earth just kept the moon. There's a couple little theories, but I'm just saying, iron is only going to survive when you're this close to the sun. So when this disk is formed, only the heavy elements are going to be able to even closely survive any kind of heat. And everything is going to end up burning up or evaporating. I'm just throwing this out there too. Right now I'm just throwing out some stuff. Okay, my main point is over. I'm just throwing out extra stuff, all right? When it comes to space, when it comes to astrophysics and space and stuff, it's not hard. It's really not that hard. All you have to do is keep in mind there are only 3 primary factors. Literally, there are only 3 primary factors when it comes to physics in space. All right, astrophysics. Literally 3. That's all. All right. Now there are infinite individual factors, yes, when it comes to sizes and densities and temperatures and all of that. But when it comes to the ultimate answer to understanding anything, the plain and simple, plain Jane factors are space, which has always existed. You cannot remove space and you cannot make space. Okay, so it is infinite. It just exists. It just is. Okay, it's the flat plane of existence. This is the flatness that we see. And the curvature is the depth. I can't stress that enough because we don't know why we see the flatness. We don't know where the curvatures come from, all this, but it's very easy to understand. The flatness is the plane of existence, and the curvature is the depth. Very easy. Product. Okay, you have your space and you have product. What's the product? Well, it's either matter or energy. Okay, one of the two. It's nuclear energy and electric energy, or it's atomic nuclei and electric covalent shells. Okay, matter is only nuclear and electric energy in matter form. Okay, that's all. So matter and energy are the product, and then you have movement. Okay, that's all you have. Nothing in space is completely stationary. Nothing stops. Okay, so there are only literally 3 primary factors: space, the product, and movement. That's it. That's all you have. And when it comes down to any kind of laws in space, you're only going to have, in infinite space, where there's no matter yet, you're only going to have the potential for occurrence and micropotential, which is the potential energy. Okay, so you're going to have potential for occurrence and potential energy, which is literally going to create a singularity. Okay, so out of the dust, a new phoenix will emerge, or new singularity, because this is all basically just energy and ash from the previous universe. It all just burnt out. No different than a star would do. And this is the secret to quarks, too. I think I've put that in a couple of videos, but I don't know if people survived long enough to get to that part. I don't even know if they'll survive long enough to get to this part of this video, because I don't know if people are even actually watching them. But just saying.